Hi girls, so this video is about the extension 1 component of inequalities, and I firstly wanted to start with a mathematics question. So let's say, for example, I asked you to solve 2x plus 3 greater than or equal to 3. Now, actually, sorry, let's make that a 0 just for the, no, let's make it 2. Let's make it 2, right. So, rather than doing this algebraically, I want to do it graphically first. So here's our graph. So we've got 2x plus 3. So it's slope 3, slope 2, y-intercept 3. So it might look something like that. Okay. So there's my 3. I should label my axes. Okay. So there's the line y equals 2x plus 3. And I want to know where it is greater than or equal to 2. So, well, that probably means that I should draw a line at 2, right? So let's do that. So here's a line at 2. Right? That is the line y equals 2. Now this point here, oops, that I will get some red ink on, there we go. That is where 2x plus 3 equals 2, right? And if you remember talking about simultaneous equations, that's how we're thinking about simultaneous equations. Kind of think of these two things as equaling y, and we say their y coordinates are the same. Now that point occurs when, so firstly, so I get 2x equals minus 1, so I get x equals minus a half. So that there is minus a half. And now, if we translate this first inequality, which is getting a bit messy now, so I might rewrite it, which says 2x plus 3 greater than or equal to 2. So that is saying, where is the line 2x plus 3 greater than the line 2, which, if we look at our diagram, is saying, where is the pink line above the green line? And we know that that is when x is greater than or equal to minus a half, because I drew it and I used algebra to find where they are the same. Okay. Now, if I solved it algebraically instead, I'll do all the usual things. So I'd, minus 3 from both sides. So to give me 2x is bigger than or equal to minus 1. I divide both sides by 2, and I don't have to flip it then, so I get that. Okay. So that's a bit of an idea as to how these inequalities are working. So now let's do something else. So let's think about when is x squared minus 4x greater than or equal to 0? Right. Sorry, that's a question mark. When is that true? Right. So again, I'm going to draw a diagram. Right. So this time I'm going to draw a diagram of x squared minus 4x equaling y. So x squared minus 4x equals y, so that's x minus 4 equals y, so that has intercepts at 0 and 4. And that's the line, the curve, x squared minus 4x. Can I squeeze it in? Just. Right. So now, the question now stands at, where does x squared minus 4x, which I've determined to be y, where is that greater than or equal to 0? So where is y greater than or equal to 0? So that is saying, where is my curve above the x-axis? Because that's when y is greater than 0. So it's this stuff here and it's this stuff here. Now that is the section of the curve that I've drawn where these things are positive. Okay, but that is not the answer I'm looking for, and I'm looking for an answer in terms of x. So hopefully it's fairly obvious to see that it's x's over here and x's over here. So the answer is x less than or equal to 0 or x greater than or equal to 4. Okay, that's how I want you to do these every single time. Another way to think about that is to say, set x minus 4 equal to 0. Alright? Because if we go all the way back to the start, all the way back here, we're saying when is it greater than or equal to 0? And you can see from the diagram that the points where it's equal to 0 is when it changes from being bigger than 0 or less than 0. So I solve that, and that gives me a region. So it gives me 0 and it gives me 4. And then what I do is in each of these regions I check whether or not the inequality is true. So over here on the left, for a number less than 0, is x squared minus 4x greater than or equal to 0? So I pick a number, and you pick a nice easy one, which is minus 1. And you just work it out, and that gives you positive 5. So it's greater than 0, tick. Then you pick a number in here, you pick 1 and you sub it in. It's less than 0, cross. You pick a number out here, you pick 5 or 10 and you check it, and it is positive. And so looking at this, it says, well, I've got ticks when x is less than or equal to 0 and when x is greater than or equal to 4. And that always works as well. Now, on to a 3-unit example. What? That wasn't a 3-unit example, I hear you saying? Correct, it wasn't. So what about this one? Oops, I didn't mean to make it y equals yet, but anyway. So let's try that one. When is 1 on x minus 2 less than 0? Now we can draw 1 on x minus 2. You could do this last year. So that's a hyperbola. Right, remember 1 on x is a hyperbola. There's 1 on x that I'm about to rub out. So 1 on x minus 2 is that shifted to the right 2 units. So we've got a vertical asymptote at 2. We've got a hyperbola here and here. Oops, the second one is wrong. There. And we want to know where that's negative. So I literally look under here and I say, where is the curve under there? Well, it's everywhere back there. And so the answer is that x must be less than 2. Not equal to 2, because clearly when it is 2, you've got an asymptote. Okay, and I'm finished. Now the technique that we're going to use is as follows. We're going to get this, and we're going to say, when is the denominator 0? Because when the denominator is 0, you get an asymptote. And when you have an asymptote, the curve changes drastically from one side to the other. Look, in this circumstance, it goes from positive infinity to negative infinity. So that's what we're going to call a critical point. Sorry, I don't know what I said. I meant x minus 2 equals 0. So x is 2. And then we do the same thing as before. We draw a little region, we look at 2, and then we pick numbers. So when x is less than 2, so let's pick x is 0, we get 1 on 0 minus 2, and that's a negative, so yes. And then we look when it's bigger than 2, let's pick 10. So we get 1 on 10 minus 2, which is positive, so no. And so the answer is x less than 2. Okay, I want to do one more. And this is the one I want to do. I want to do y equals, sorry, why did I keep doing that? I want to do x over x squared minus 4 is greater than 0. So I'm going to draw the graph for you. You don't need to be able to draw this graph as quickly as I can, ever. I may also be cheating, I may have looked it up beforehand, who knows. So, I've got asymptotes at 2 and minus 2. If you think about y, if you look at when x is 2 and minus 2, that equals 0. turns out that the curve, oops, stop doing that, go away, there you go. The curve looks like that. Now you can look at this immediately and see the answer, right? You can see the answer is positive, so it's this stuff here, and it's this stuff here. So the answer is x between 2 and 0, and also x bigger than 2. Now let's work out a way to do that algebraically that's nice. So here's what you do every time. The first thing you do is you say, when is the top 0? So the top in this case is x, I'm just looking at that. So x is 0, okay. So that's something I'm going to remember. And then you say, when is the denominator 0? Okay, x squared minus 4 is 0. So x minus 2x plus 2 equals 0. So x is plus or minus 2. The reason we do that when we look back at the graph is because those are the points when the curve switches between positive and negative. We don't know which way yet, but that's when it switches. So here's our region again. We've got our numbers. We've got 0, we've got 2, and we've got minus 2. And again, we just pick nice numbers, sub them in and see if they work. Give myself some space here. So let's pick a number bigger than 2. So when x is 10, I get 10 on 10 squared minus 4. Positive on positive, so it is positive. Tick. Next, let's pick a number between 0 and 2. So you should pick 1, or you're being very silly. So that's negative, right? A positive on a negative. So no, that doesn't work. And I'll leave it to you to check, but yes, that will work if I pick minus 1, and no, that won't work if I pick minus 10. And I look at my diagram and I say, oh look, x is between 0 and minus 2. Whoops, come on. And x is bigger than 2. And that's how you do it every time. Okay, we'll stop there for today, and we'll keep going in class tomorrow morning. I'll see you then.